హలో TSAT వ్యూయర్స్, ఈరోజు మనం ర్యాండమ్ వేరియబుల్స్ యూనిట్ స్టార్ట్ చేస్తున్నాం. ఫస్ట్, వాట్ ఈస్ ఏ ర్యాండమ్ వేరియబుల్? Random variable is a variable which assumes the values of the outcome of the random experiment. We can also say that random variable is a function defined over a sample space of the random experiment which considers the different values and also which has each and every, and has separate probabilities for each and every value. Now let us consider small examples. I'm doing an event tossing two coins. So what are the outcomes when two coins are tossed? Head is one of the outcome. Head, tail, head, and tail. These are the possible outcomes of the two coins. Now I'll assign a random variable x which takes the values of number of heads. This random variable x takes the number of heads occurred in the outcome. See, here number of heads is 2, so the random variable x takes the value 2. Alage ikkada 1, so the random variable x takes the value 1. Alage ikkada 1, ikkada 0. So x is a random variable which takes the values 0, 1 and 2 in this experiment. Now, how to determine the probabilities when the random variables is like this is given? Now, probability of x is equal to 0. So, probability when x is equal to 0 ante dani meaning enti? Probability of 0 heads occurring. Probability of 0 heads occurring, which is equal to 0 heads ante 0 any times repeat avutundi ikkada? Only one time, divided by total number of outcomes anni 4. So, the probability of getting 0 heads is 1 by 4. Alage probability of getting 1 head. Probability of getting 1 head ante x value 1. Probability of getting 1 head. So x value 1 ఎన్ని సార్లు వస్తుంది ఇక్కడ? 2 times వస్తుంది. So 2 by total number of outcomes 4, that is 2 by 4. అలాగే probability of x is equal to 2 అంటే probability that 2 heads are occurring. Probability that 2 heads are occurring, which is equal to 2 ఎన్నిసార్లు రిపీట్ అవుతుంది ఇక్కడ? Only one time, 1 by 4. This is how we find the probabilities corresponding to the random variables. Now, so we have two types of random variables. And the first one is discrete random variable, alage second one is continuous random variable. సో అలాగే మనకి డేటా క్లాసిఫికేషన్ చేసేటప్పుడు ఎలా చేసాం? డిస్క్రీట్ డేటా అండ్ కంటిన్యూస్ డేటా. సేమ్ ఇలా ర్యాండమ్ వేరియబుల్స్లో కూడా డిస్క్రీట్ ర్యాండమ్ వేరియబుల్ అండ్ continuous random variable. So this discrete random variable will consider the integer values. So just like in the last example we have seen, x is considering the values 0, 1 and 2. That's a perfect example for discrete random variable. Whereas this continuous random variable will assume the values within a certain limits, just like a less than or equal to x less than or equal to b, like this. Now, the best example we can give for continuous random variable is the weight of student in a class, the weight of students in a class. Let us suppose 50 to 70, the range. So 50 to 70 మధ్యలో ఏ వాల్యూ అనేది తీసుకోవచ్చు ఆ random variable. Okay, it may be 50.4, 50.5, 60, 60.2, maybe anything within the limits it will take. Now we'll see you'll see discrete random variable and continuous random variable in detail. So first, discrete random variables. Now let us consider a random variable x. It is taking the values 0, 1, 2, 3, so on up to n, and the probabilities corresponding to the random variables is given as, let us consider p0, p1, p2, p3, so on up to pn. Now probability mass function is defined as when probability of x is equal to xi is equal to P of xi, where xi consider the values 1, 2, so on up to n. Otherwise, 0 otherwise. So what is the meaning of this? So now I will name this random variable 0, 1, 2, 3, so on up to n as x0, x1, x2, so on up to xn. Probability of x is equal to xi. Let us consider I is equal to 2 here. Let us consider I is equal to 2 here. Probability of x is equal to 2 is equal to, so మనం value 2 తీసుకున్నాం. So ఈ 2 is lying between the range 0 to n. So x is equal to 2 is equal to P2. That is the probability when the random variable x is taking the value 2. అలాగే if I consider I is equal to some n plus 1, probability of x is equal to x of n plus 1, which will be equal to 0 because this n plus 1 is out of the limit. So xi is assuming only 0, 1, 2, 3, so on up to n. So when you take I is equal to n plus 1, its probability will become 0. There are 2 points you have to remember. The probability, what are the probabilities it is assuming? P0, P1, P2, P3, so on to Pn. Let's consider Pi, where I takes values from 0 to n. It must be greater than or equal to 0 always. In the second property, when you add all the Pi's, where I takes values from 1 to n, it must be equal to 1. So these are the 2 properties you have to remember. Next, discrete probability distribution. So this probability distribution is nothing but cumulative of probability. Cumulative of probability. So మనకి క్లాసిఫికేషన్ డేటా క్లాసిఫికేషన్లో ఏం చేస్తాము, లెస్ దెన్ క్యూములేటివ్ ఫ్రీక్వెన్సీ, గ్రేటర్ దెన్ క్యూములేటివ్ ఫ్రీక్వెన్సీ ఫైండ్ అవుట్ చేస్తాం కదా. ద సేమ్ వే ఇక్కడ డిస్క్రీట్ ర్యాండమ్ వేరియబుల్స్లో కూడా డిస్క్రీట్ ప్రాబబిలిటీ డిస్ట్రిబ్యూషన్ ఈస్ గివెన్ బై ద క్యూములేటివ్ probability and it is denoted by capital F of x, which is given by summation Pi, where I takes from values 1 to n. So actually that is equal to 1. Just a second. Okay, and it is denoted by capital F of x, which will be equal to probability of x less than or equal to x, and it is equal to summation P of I, where I takes from values 1 to small x, capital X. Okay, we have to very clear. So this is nothing but addition of probabilities till x, small x. So what we are doing here, cumulative, we are adding the probabilities till x. That is nothing but the cumulative of the probability. So let's take a small example depending on discrete random distributions, discrete random variable. See, here x is assuming the values 0, 1, 2, 3, so on up to 8, and the P of x is given a, 3a, 5a, 7a, so on up to 17a. First bit is determining the a value. So in order to determine the a value, what we have to do? So to determine a value, first thing you do is add all the probabilities. We know the property P of I, where I takes from 1 to n, it must be equal to 1. Now add all the probabilities. A plus 3a plus 5a plus 7a plus 9a plus 11a plus 13a plus 15a plus 17a will be equal to 1. Now add everything. 20, 40, 60, 81. So 81a is equal to 1, a is equal to 1 by 81. Probability of x less than 3. Probability of x less than 3. See here, in order to find the probability of x less than 3, we have to consider probability of x is equal to 0 plus probability of x is equal to 1 plus probability of x is equal to 2 till 2. It is saying just less than 3. So 0, 1 and 2 we have to consider. Now add the probabilities. 0 ఉన్నప్పుడు ఎంత 1 by 81, 1 ఉన్నప్పుడు 3a, సో 3 into 1/81 that is 3/81 ప్లస్ 2 ఉన్నప్పుడు p of x ఎంత 5a, సో 5 అన్నప్పుడు 5/81 which will be equal to 9/81. So that is the value. Now p of x is equal to 3. x is equal to 3 ఉన్నప్పుడు ఎంత, x is equal to 3 ఉన్నప్పుడు 7a p of x. So 7 into 1/81 that is equal to 7/81 is our answer. So remember this bit, we will discuss this point in the continuous random variable also. So probability at a single point. So here discrete random variables, so we are able to find the probability at a single point. Whereas in the continuous random variables, we cannot find the probability at a single point. We will discuss that in the continuous random variables topic. Now, the next problem is probability of 2 less than or equal to x less than or equal to 5. అప్పుడు ఏం చేయాలి మనం, probability of x is equal to 2 plus probability of x is equal to 3 plus probability of x is equal to 4 plus probability of x is equal to 5 మొత్తం యాడ్ చేయాలి. సో యాడ్ చేసినప్పుడు ఏమవుతుంది, 2 3 4 5 5a 7a 9a and 11a which will be equal to 32/81. సో అలాగే ఇక్కడ చూడండి p of x less than or equal to x less than or equal to 5. సో ఇక్కడ మనం ఏం చేయాలి, probability of x is equal to 3 plus probability of x is equal to 4 ఈ రెండు వాల్యూస్ అజ్యూమ్ చేసుకోవాలి. ఎందుకంటే probability of 2 greater than or x greater than or equal to 5. Okay, fourth bit, the probability of 2 less than or equal to x less than or equal to 5. So here we have to consider only probability of x is equal to 3 and x is equal to 4 because there is no equality sign here. 2 and 5 are excluded here. So probability of 3 plus probability of x is equal to 3 plus probability of x is equal to 4, that's nothing but 7a plus 9a which is nothing but 16a 16/81. Now continuous random variables. So we already discussed the continuous random variables will take the values within a certain limits. So check here, what's probability density function. Now if a function f is said to be a probability density function, it has to be satisfied two conditions. The first one is integral over -infinity to +infinity f of x dx must be equal to 1. And the second property is f of x must be always greater than or equal to 0. That is nothing but it must be a positive function. And integral over -infinity to +infinity f of x dx must be equal to 1. So when these two conditions satisfy, then we can say that this f of x is nothing but the probability density function. Now continuous probability distribution. See, so it's nothing but the cumulative probability, the same thing which we are discussing the discrete random variables. Cumulative probability x greater than or equal to x, which is given by integral over -infinity to x f of x dx. f of x dx. See here, in మన డిస్క్రీట్లో ఏం చేస్తున్నాము, p of x less than or equal to x అంటే summation I is equal to 1 to x p of I ఫైండ్ అవుట్ చేస్తున్నాము. ఇక్కడ డిస్క్రీట్లో మనం సమ్మేషన్ యూజ్ చేస్తున్నాము, అలాగే ప్రాబిలిటీస్ యూజ్ చేస్తున్నాము. అదే కంటిన్యూస్లో ఇంటిగ్రల్ యూజ్ చేస్తున్నాము అండ్ ఫంక్షన్స్ యూజ్ చేస్తున్నాము. సో దట్ ఈస్ ద డిఫరెన్స్ బిట్వీన్ ద discrete random variables and the continuous random variables. Now we'll just check the properties. First one, the probability at any point, at a single point, it must be equal to 0 in case of continuous random variables. That is, if you want to find the probability at a single point x is equal to x, is nothing but integral over a to a f of x dx. A to a f of x dx and it will be equal to 0. Okay, that shows that probability at any single point in a continuous probability distribution is equal to 0. Alage p of a less than or equal to x less than or equal to b will be equal to p of a less than or equal to x less than or equal to b will be equal to probability of a less than or equal to x less than or equal to b, because the probability at any single point is equal to 0. It doesn't matter whether you keep the equality sign or not, and it is given by, and which is also equal to probability of a less than or equal to x less than or equal to b, and which is given by integral over a to b f of x dx. So integral over a to b f of x dx. Next, mathematical expectations. So first, what is this mathematical expectation? We'll see. Let us consider a random variable x. It is taking x1, x2, x3, so on up to xn values, and the corresponding probabilities are small p1, small p2, small p3, so on up to small pn. Now, mathematical expectation is denoted by expectation of x, e of x. We'll read that as expectation of x, which is given by the product of random variable and the probability, that corresponding probability, that is x1 into p1, x2 into p2, x3 into p3, so on xn into pn, and we have to add all this product, which will be equal to summation I is equal to 1 to n 𝗧𝗦𝗔𝗧. Expectation of x. Now, సో ఇక మనకి ఎక్స్పెక్టేషన్ ఆఫ్ ఎక్స్ అంటున్నాం కాబట్టి ఇక్కడ మనం ఎక్స్తో మల్టిప్లై చేస్తున్నాం. అలాగే ఎక్స్పెక్టేషన్ ఆఫ్ ఎనీ ఫంక్షన్ జీ ఆఫ్ ఎక్స్ అనుకున్నాం అనుకోండి, ఇట్ విల్ బి సేమ్ సమేషన్ జీ ఆఫ్ ఎక్స్ ఇంటూ పిఐ వేర్ ఐ టేక్స్ ఫ్రమ్ వాల్యూస్ 1 to n. ఆర్ ఎక్స్పెక్టేషన్ ఆఫ్ ఎనీ కాన్స్టెంట్ సమ్ సి తీసుకున్నాం అనుకోండి, విచ్ విల్ బి ఈక్వల్ టు సమేషన్ దట్ కాన్స్టెంట్ ఇంటూ పిఐ వేర్ ఐ టేక్స్ ఫ్రమ్ వాల్యూస్ 1 to n. Now, we'll see the few properties of this mathematical expectation. First one, addition of the random variables in a mathematical expectation. So expectation of x plus y will be equal to expectation of x plus expectation of y. Alage second property, expectation of some constant into x, which will be equal to a into expectation of x. Alage third one, expectation of x plus a, which will be equal to expectation of x plus a. The same way, expectation of x minus a, which will be equal to expectation of x minus a. Expectation of x by a, which will be given by expectation of x divided by a. So these are the properties of the mathematical expectations. Now we'll see one new thing here, variance, which is denoted by v of x, which is denoted by v of x. Now we will establish a relation between the expectation values and the variance. So this variance of x is given by expectation of x minus expectation of x whole square. The same thing we can write as expectation of x square minus expectation of x whole square. Both are equal. When you expand this, you will get the below equation. So this is very important relation. Variance of x is equal to expectation of x minus expectation of x whole square, or we can write the same, we can write as expectation of x square minus expectation of x whole square. Now we will see the properties of variance of x, that is v of x. Now we will see the properties of a variance of x, that is v of x. V of x is given as, we just seen the property, we have just seen the formula. Okay, expectation of x minus expectation of x whole square. The same thing we can write it as expectation of x square minus expectation of x whole square. Now, variance of x plus a, which will be equal to variance of x. Variance of a into x, which will be a square into variance of x. In the same way, variance of x minus a will also become variance of x. It doesn't change. Variance of x by a will become variance of x divided by a square. These two properties shows that the variance of x doesn't change if we change the origin. That is nothing but the change of origin will not have any effect on the variance. And the below two properties shows that the change in the scale. So it shows that the change in the scale will affect the variance. So there is one more point here, you have to just remember this. Expectation of any constant will be a constant itself. Okay. Now we will see a small example on this mathematical expectation. Then we will see the continuous mathematical expectation in terms of continuous random variables. Check the example here. Find the expected value of x where x represents the outcome when a die is thrown. So first, take a random variable and probability of x's. So the random variables will take the values 0, 1, 2, 3, 4, 5 and 6. Those are the possible outcomes. The probability of getting 0 is 1 by 6, the probability of getting 1 is 1 by 6 and it is equal for everything. Now we have to find the expected value of x, expectation of x. Expectation of x is nothing but what you are saying, summation xi into pi where I takes from values 1 to n. ఇక్కడ ఏంటి 0 into 1 by 6 plus 1 into 1 by 6 plus 2 into 1 by 6 plus 3 into 1 by 6 plus 4 into 1 by 6 plus 5 into 1 by 6 plus 6 into 1 by 6. Look at the example here. Find the expected value of x when x represents the outcome when a die is thrown. Let us consider the random variable which takes the values 1, 2, 3, 4, 5 and 6. And the respective probabilities p of x is nothing but 1 by 6, 1 by 6, 1 by 6, 1 by 6, 1 by 6 and 1 by 6. So now expectation of x, which is nothing but summation xi into pi where I takes from values 1 to n. We'll write this as 1 into 1 by 6 plus 2 into 1 by 6 plus 3 into 1 by 6 plus 4 into 1 by 6 plus 5 into 1 by 6 plus 6 into 1 by 6. Denominator 6 keep it constant. 1 plus 2 plus 3 plus 4 plus 5 plus 6, which will be equal to 6 plus 4 10, 20, 21, 21 by 6. So that is the expected value. Expected value is 21 by 26. Now we will see the continuous. Now we will see the expected values in the continuous distribution functions. In the discrete distribution functions, we have seen expectation of x is equal to summation xi into pi where I takes values 1 to n. The same way, in a continuous distribution functions, expectation of x will take the formula integral over x into f of x dx where x, limits will be. So in a continuous distribution function, expected values will take the formula integral over minus infinity to plus infinity x into f of x dx. The same way, expectation of some function g of x will be equal to integral over minus infinity to infinity g of x into f of x dx. In the same way, expectation of some constant will be equal to integral over minus infinity to plus infinity is constant into f of x dx. Now we'll see the applications of the expected mathematical expectations. So moment generating function and the cumulate generating functions. So this moment generating function, which is given by expectation of e power it. So it's the moment generating function and the cumulative generating function, which are the applications of the mathematical expectations. So this moment generating function is given by expectation of e power tx, which will be equal to summation e power txi into pi, where I takes from values 1 to n. So when you, and in the same way, cumulate generating function is given by expectation of e power itx, which is equal to summation I is equal to 1 to n e power itxi into random variable. Sorry, this is in case of discrete random variables. So in case of continuous, like minus infinity to plus infinity e power tx into f of x dx. The same way, cumulative generating function is given by minus infinity to plus infinity e power itx into f of x dx. In the next class, we will discuss about discrete probability distributions and the continuous probability distributions. Thank you.